Good afternoon. Can you hear me? So, my presentation, I will speak about global policies of routing, and in particular about the influence of internet delays. So, network delays, what is it? First of all, it is the most important characteristics of the service quality, and we would like to have minimum delays. The less delay, the better. But this ideal is unreachable. First of all, because one of the components of network delays are delays connected with the distance. Until we can cheat the laws of physics and move faster than speed of light, we will not be able to remove these delays. However, besides the delays connected with distance, there are other factors which influence these delays, and I will talk about these delays in my presentation. This will be global policies of routing. And of course, as we are in Kazan, we will consider this situation on the example of the Volga region. So the clicker is not working. Okay, next slide, please. At first, a couple of words about the Volga region itself, about geographical data. This is a quite large region, one of 12 economic regions of Russia. It consists of 8 entities of federation. It has 17 million of population, which is approximately 1/8 of the whole of population of Russian Federation. Most of this population live in the cities, including 3 cities with a population of 1 million. That's why we will pay more attention to these cities. So, what is a delay from the Volga region? From the point of view from a common user, it is first of all delay to the most popular resources, in particular search engine news resources, mail sources. We will name them content generators. So let's wait for the slide to appear. So the clicker is not just working, so I will continue talking. So, from the point of view of common user, most interesting are delays up to the content generators. There we have top 5 content generators in Russian Federation. They are listed here. The next slide, please. And accordingly, we need to understand what is a delay for the Volga region. First of all, let's find out whether the traffic is local. For that, we will have a look what points of traffic exchange are there in the Volga region, and we will see that there are such points, several of them. However, unfortunately, content generators are not represented in these points. That's why we can make a first simple conclusion that the traffic from the Volga region to content generators will pass via IP transit, and these delays are mostly defined by the delays in IP transit. Next slide, please. So, we have got the first conclusion that the delays up to content generator are defined by IP transit. Maybe this fact by itself is not bad, because we might have the situation that the delay to the content generators will include only the part concerning the distance and no other factors. To find out whether it is true or not, let's consider the average delay from the largest IP transit operators to the Volga region. Next slide, please. This data was collected into this table. So we took the largest operators presented on the previous slide and counted delays till several autonomous systems of Volga region, calculated the average and statistics, and put them into the table. The first thing which we can say at once is why these numbers are so different. In the left column, we can see the delays up to 15 milliseconds. This is the delay which is defined by the distance from Moscow to the Volga region. But if we look to the average, we will be able to see that they are much higher. And this makes us to get suspicious that there might be some other factors. And where is the median? We also calculated median. It does not differ from average very much. Median is a little bit lower than the average, and this large amount of average is connected with the output. Next slide, please. And our next step in studying delays is building a distribution graph of delays. On this slide, you can see the distribution for Samara. However, for two other cities with million population, for Kazan and Volgograd, the distribution is practically the same. What can we see from this distribution?
First of all, for the delays from 15 to 30, you see something like normal distribution, and that is why we can see that this is exactly the same delays which should be. But after that, this distribution goes astray, and you see that the delays 40, 45, and more than 60 have these two humps. So here you see, we have to understand what these anomalies are about. So we found several reasons of this behavior, and one of these reasons is that on the next slide. The traffic looks like that because of the wrong connections between the providers. The easiest example of the behavior is that the route which from Moscow to Volgograd, and you see it takes about 120 milliseconds for a very simple reason, because traffic goes through Europe. And in this situation, there is no connection between two providers, so that is why traffic has to go through the cable environs and 1233 through Germany. For example, now this ping connection, there is ping connection between two operators. Does the problem disappear? Well, not completely, because this pinning connection is anywhere, but not the place we want it to be. For example, look at this. Here is the connection between two providers. Is in, yes, we have it, but it's in Kiev. So it goes from Moscow to Kazan for 40 milliseconds through Kiev. So these two reasons, undoubtedly, of course, the most the simple ones and the widespread. So we found cases which cannot be described by them. So there is a third reason, which we can't understand. We found such route from Kazan, from Moscow to Kazan, where we see between to provide Rostelecom and Transtelecom 5 milliseconds delay. From Kazan to Moscow, from Moscow to Kazan, the difference is 5 milliseconds. When we saw it, we were surprised. So we thought that it's maybe some different overload on the rotor, and looked at other directions on the next slide. And we found exactly the same thing for Samara and for Volgograd. The reasons for this phenomenon, there can be several ones. Probably it's maybe shaping, deprioritization. Maybe it's just because that the Rostelecom and Transtelecom looks like that. That's how they work. In any case, we really would like to have the correct answer from our colleagues from Rostelecom and Transtelecom. But for now, we go to the next reason, the last reason. These are root leaks. What is root leaks? Root leak is the situation when some brave autonomous system tries to play the IP transit and sends prefixes from pings or providers to other pings or providers. So the transit is terrible, which leads to big delays, and in the base case, and even to losing packages and losing accessibility. Not only the system suffers in this case, but also other prefixes which were lost. And that's exactly the case which we have on this slide. For example, we wanted to go from Moscow to Samara Technical University, and we get this terrible route, this scary route. And the arrows shows the difference. The upcoming arrow, the horizontal arrows are appearing, and the you see the leakages and how it goes between different providers. Well, in any case, the situation is quite unpleasant. As for the root leaks, so you can see the origin, the prefix, and the problematic path. The next slide is slide. So we considered the delays from Moscow to the Volga region, and now let's look at try to cast light on what's going on and try to understand the problem. We'll have to make the same table with the average delays, not from Moscow to the Volga region, but from Volga region to Moscow. And what we see, that the delays are the same, and not just the same, they increase 2 times. So it brings us to a conclusion that if delays are twice as they're from Moscow to Volga, so probably traffic goes through Moscow. Well, the situation isn't always that bad, because it can be even worse. Here we see this overlapping of the absence of the peering joint, and the traffic from Kazan to Kazan can go up to 130 milliseconds. So then we had routers in Germany, as you remember. It comes from Kazan to Germany, then to Moscow. And after all what I have just said, let's think about what is the perfect world internet. And first of all, the operators of one region should have the normal peering joints. But it's not enough, because this joint must be in the region and must be geographically distributed. And of course, we should have the network neutrality, and the joints of some operators with other operators should be the same, having the same policies, without any shaping or deprioritization towards other operators. And of course, the network engineers which do it, they must be qualified enough so that no root leaks could happen. But there is no such thing as perfect world. Nevertheless, we can try to improve existing world, get it closer to the ideal one. So this is my closing remark. Thank you very much for your attention. Can I have a little comment and question? Yes, sorry for my voice. I'm Alexander from Moscow. So you mentioned several problems which you didn't say that not of the generations was on the IX, and you named Yandex. I can tell you for sure that we have many years of experience with Yandex. And Yandex is everywhere. Just look at Looking Glass. So probably was a mistake. But in general, the idea is very good that the peering must be local, and the routes should be straight, not zigzagging. Thank you for the comment. More questions? I am from a small company. My name is Dmitry, and you measured delays, and what can I say? Did you take into account that operators can have a joint when you talk about the 15 milliseconds in Moscow, but it was going, you didn't see it in the routing? On the specific examples, it's not that I'm just talking about shaping or prioritization. Maybe you just don't see the route correctly. Maybe, but in the examples, they show us that the problem is, as I told you, I can't find any other explanation for this. On the third or the fourth hop, we saw the problem on the joint from Transtelecom and Rostelecom. The route begins in Transtelecom company up to 34th hop. It goes to the router in the destination city, and on the next hop, we see the significant increase of delays. The routes are symmetrical. Yes, it's probably distance. And one more comment: what prevents you from what prevents your local operators to install free applications? If you have these problems, what prevents you from installing the content generators from the cache servers? Yes, of course. We can talk not only just how to giving access to content generators and how to make access faster, better. No, it's this is the first consideration. Is this is the message to start studying the problem, and many IP transits, they have cache in the content generation. So. But actually, we calculated the delays from Volga region to content generator. The situation is not drastically different, which I gave you in my examples. It's just from Moscow. To analyze this situation from Moscow is more convenient, so we have more points. But the picture is basically the same. Thank you. A question. May we come back to the slide where you showed a leak. Can you show the slide with the root leaks? Why do you think that there is some deliberate action? If it's a deliberately organized route, why do you call it leak? Maybe it's just a policy of routing, and we're just trying to you were trying to say that this is a root leak which happened because Beeline and Eliton just didn't establish peering joint. No, what we call leak, if an autonomous system gives and announces from its provider and gives it to different provider, so in this sense it automatically becomes a transit for the given prefix, and the whole traffics automatically go through it. So this behavior is not normal. So it couldn't be a deliberate action, conscious action. So you think that if there is such transit, it's a leak, it's always bad? Well, yes, these autonomous systems, they're usually not big, but they are not designed to do it. So if you wrote in a routing policy, maybe it's a policy, maybe it's just an honest announce. Well, maybe yes. But maybe no, in the sense that this analysis should be more sophisticated. It's not obvious problem, which a lot of people don't even suspect about. It's a consistent routing policy. The efficient position which we have at RPDB, these are the records of the owner for himself. And the owner for further autonomous system don't have right to interpret how it's written, what's written there. It's a notebook for something personal, and RPDB is the inconsistent thing which I don't think you have to use it for any purposes. Just don't use it. We don't have any other source of information. Well, you actually just proved what I just said. I wanted to ask, these 6 numbers which you've written in the, are they illustrating what? Because I don't see any connection between the upper part and lower part of the slide. And these 2 hops are just, I don't understand. Why did you give this? Something is redundant here. Well, no, maybe some of these autonomous parts, it doesn't add itself to the trace route, but the traffic is basically the same. First, what is missed here, missing is, well, if you consider the current records in RPDB, the actual, so the redundant are 4ths and 5ths, because 9 to 8, it's just not here. I mean, it just doesn't belong here. Well, I understand your idea, but I think the illustration which you have chosen is not good. Well, the problem is that this gets the prefix from provider. Yes. So in here, I just don't understand what is it. Okay, we can talk a lot about these things, and my idea is that the message what you're trying to say that just doesn't correspond to facts you give. I have been working a lot for Trans Telecom, and I would like to protect the position of the company I work for. So it's not always the incompetence of the engineers. What we have, and it's sometimes we have not optimal routes, and sometimes it's not a technical problem.
Make a clarification about RIPE database, because RIPE database basically has two parts, and because the comment said the RIPE database is not reliable. One part is registry data, so that's when we give out resources to people, AS numbers, IP addresses, IPv6 addresses. That one is pretty much accurate and reliable, and you can really rely on that data. We do audits, they're coming directly from our registry. So the registry part of RIPE database is quite reliable, and you can seriously rely on that information. Then it has an IRR, that's a routing, internet routing registry. The registry part, which is also part of the RIPE database, that's not that reliable by design, but it's still among the other IRRs. There are about 30 IRRs in the world, and like 5 of them are really active. RIPE database is the most used IRR in the world. So yes, the routing information in RIPE database is not that much reliable, but that's by design. And if you're looking for an alternate registry for route information, you can look into RPKI and other things. But just saying RIPE database is unreliable is, to be honest, not accurate.
Okay, thank you.
Евгений, спасибо большое.
Thank you very much.